right now, something is happening that will look absolutely insane when people read about it 50 years from now. Humanoid robots have crossed over from concept sketches into actual shipping products. Some of them can sweat. Some of them can feel your touch. Some are already clocking shifts inside factories. This is not hype. This is documentation of a moment we are living through in real time. So let's walk you through 5 machines that represent what it actually means to build something human-like in 2026. At number 5, we have the robot that copies biology down to the bone. Polish startup Clone Robotics has built Protoclone around a radical idea. Not just making a functional robot, but recreating a human body from the inside out. Protoclone features 206 bones, articulated joints, ligaments, and over 1,000 synthetic myofibers that mimic real muscles. These fibers attach to the skeleton at anatomically accurate points, just like in humans. The system includes 500 sensors and supports more than 200 degrees of freedom, far beyond typical robots, making it one of the closest attempts at true biological mimicry. When footage first appeared in 2025, it quickly went viral. Viewers were split between awe and discomfort. The robot, shown suspended in a harness, has translucent skin with visible muscle movements underneath, both fascinating and unsettling. As Darsleeper put it, the design is as cool as it is creepy. Right now, Protoclone runs on pneumatic systems, using pressurized air to move its muscles. The company plans to upgrade to hydraulics for better strength and precision. It even has a bio-inspired cooling system. It sweats to prevent overheating, mimicking human temperature regulation. Co-founder Lucas Koljic has been clear about the goal: machines indistinguishable from humans. The company has even criticized approaches like Tesla's, arguing that muscle-based systems offer advantages over rigid actuator designs. The biggest limitation so far is mobility. Protoclone cannot walk independently yet and still relies on a harness. According to the team, the issue isn't hardware, it's software. The control systems must learn to handle biology, not just mechanics. Clone Robotics isn't just building robots, they're attempting to build something much closer to a human. At number 4, we have the robot already working in factories. Boston Dynamics has spent over 30 years refining real-world robotics, and its all-electric Atlas, unveiled commercially at CES 2026 in Las Vegas, shows just how far ahead it is in physical performance. Atlas stands about 5 foot 9 inches and weighs 200 pounds. It uses electric actuators capable of full 360-degree joint rotation and combines LiDAR, stereo vision, depth sensors, and RGB cameras for real-time awareness. Its AI runs on onboard NVIDIA processors, allowing it to operate dynamically in complex environments. What sets Atlas apart is simple: it's already working. Not in demos, but in real industrial settings. At Hyundai's Georgia plant, Atlas is actively sorting parts and handling sequencing tasks alongside more than 1,000 robots and 1,500 human workers. In 2025, Boston Dynamics partnered with Toyota Research Institute to demonstrate a large behavior model powering Atlas. This allows the robot to perform long sequences of tasks that combine movement and object handling without traditional programming. Instead of writing new code, engineers can train new behaviors using modern AI techniques. The commercial reveal came during Hyundai's CES 2026 keynote, and every Atlas unit for 2026 is already sold out. Hyundai received the first deployments, while Google DeepMind plans to use Atlas as a platform for training advanced AI models. With prices ranging from $150,000 to $420,000, Atlas is clearly enterprise-level infrastructure. At number 3, we have a robot that reads your face. While Atlas focuses on physical capability, EVA AI targets something entirely different: human emotion. Built by IO Technology under the Rob Nova AI brand, EVA debuted in December 2025 with a focus on realistic interaction. EVA uses a 3-layer sensing system and bionic electronic skin developed with the Chinese Academy of Sciences. It reads emotions through text, voice tone, and body language, then responds with subtle facial microexpressions, the small details that make conversations feel real. Its design comes from a former Marvel Studios prop specialist, which helps avoid the uncanny valley effect. The AI system was led by a PhD-level expert from the University of Washington, emphasizing both technical depth and human realism. EVA isn't meant for factories, it's built as a companion. The goal is to reduce loneliness by creating interactions that feel emotionally genuine, not scripted. While robots like Atlas excel at physical labor, EVA focuses on connection, something increasingly important as robots move into homes, hospitals, and elder care, where emotional intelligence can matter as much as physical ability. And on our second last number, we have the technology that lets robots feel. JQ Industries took a different path. Instead of building a full humanoid, it focused on a missing piece nearly every robot lacks: the ability to feel. The company developed a fabric-based electronic skin using piezo-resistive tactile sensors, woven fibers that wrap around a robot like clothing. When applied to platforms such as the Unitree G1, the entire surface becomes touch-sensitive. Even light contact is converted into electrical signals, measuring pressure, deformation, and slip in real time, all processed through AI. Its glove system delivers multi-point tactile feedback across the palm, detecting forces as low as 0.01 newtons and up to 3,500 kilopascals. That range allows robots to sense everything from a gentle touch to a firm grip. In real use, this changes everything. Robots can instantly stop when unexpected contact occurs, preventing damage. They can distinguish between a tap, a push, or a hug and react appropriately. That level of sensitivity is especially critical in elder care and rehabilitation, where safe, precise interaction matters. By mid-2025, JQ Industries was already working with multiple humanoid manufacturers, moving toward large-scale deployment. Touch is central to human interaction. Electronic skin is the first scalable step toward giving robots that same capability. And finally, we have the one going for mass scale. Tesla is approaching the problem from a completely different angle: scale. Its Optimus Gen 2 robots are already deployed in factories in Fremont and Texas, handling tasks like sorting, transport, and inspection. The newer Gen 3 hands push dexterity further, with 22 degrees of freedom and a compact design that keeps all actuators in the forearm. Tesla is now transforming its Fremont lines into a dedicated Optimus production hub, targeting 1 million units per year, while expanding in Texas toward a long-term goal of 10 million annually. Progress hasn't been flawless. During the January 2026 earnings call, Elon Musk admitted the robots are still in a learning phase and not yet performing fully useful work. Production targets slipped, and Gen 3 development is behind schedule. But Tesla's real advantage is its data strategy. Each deployed robot collects massive amounts of training data, creating a feedback loop competitors may struggle to match. Bringing in Ashok Eluswamy, who led Autopilot, signals the approach clearly: treat robotics as an AI problem first. If Tesla achieves its goal of pricing Optimus under $20,000, far below systems like Atlas, the economics of humanoid labor could shift dramatically. 5 systems. 5 completely different interpretations of what human-like means. Clone Robotics is chasing anatomical perfection. Boston Dynamics is already delivering real-world performance. EVA AI focuses on emotional intelligence. JQ Industries brings touch into the equation. Tesla is betting on scale and cost. The humanoid machines that eventually enter homes, hospitals, and workplaces will likely combine all of these strengths: natural movement, real capability, emotional awareness, tactile sensitivity, and mass production. We are not fully there yet, but the gap is closing faster than most people think.